Let me start my quiz.
Sabe do outro meu telefone? Pede o Ivanovic.
So I talked to the teacher today, but he had a really bad signal, so we weren't on for very long. But he said we didn't have to record the review, but I'm going to record it anyways, just in case Edgar and Greg have a question on something that we've gone over.
Said we don't need to record, just to do the quiz.
Yeah, because he said there's no discussion to post it on. So
okay.
He said we don't have to record it. But like I said, I'm going to record it just in case Greg and Edgar have a question.
Okay. Are you going to meet them tomorrow?
Yeah, I'm going to try to meet with them tomorrow and see if we can go over any of these ones that they need. So, alrighty, I'm ready.
Okay.
I'm going to open up those. Okay, for the next 4 questions, identify the one hypothesis test that most appropriate to the given situation. In an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational levels: high school, undergraduate, master's degree, and doctoral degree. The people who manage successful startup companies in the United States and Korea. Of the people who manage successful startup companies in the United States and Korea. You want to determine if the educational level of managers of successful startup companies is independent of the country they are from. Which hypothesis test would be most appropriate for this analysis? The one sample Z, one sample T, paired T, independent sample T, ANOVA, test of 1 proportion or test of 2 proportion, or the chi-square test of independence.
This is not ANOVA.
It's not ANOVA, no.
It's not ANOVA.
And it's not going to be a Z because we don't have the standard deviation.
Yeah.
And I don't think it's going to be a one sample or a test of 1 proportion. See, one set of data compared educational levels. And they're talking, okay, so if we think about this, are they talking about something that's categorical or quantitative? They're asking about high school, comparing educational levels. Is educational levels a number?
No.
No. So it's going to be a proportion, and since I don't think it's going to be the, let's see, high school. Compared educational levels, a high school, undergraduate degree, master's degree, and doctoral of people who manage successful startup companies in the United States and Korea.
Is this 1 proportion?
I want to say it might be 2 proportion.
Yeah, I put test of 2 proportions here.
Okay, that's what I got too.
Maybe maybe I'm confused about the definitions of one proportion and two proportions.
So one proportion is when you just have one thing that you're looking for. Like there's 25 out of 100 people,
Yeah.
and you want to know what the proportion is
That is
of those people that have that characteristic or whatever. Two proportion. The reason I think it's two proportion is because there's United States and Korea, but there's also the chance that it's this chi-square test of independence because they're looking at high school, undergraduate, master's, and doctoral degrees.
they are comparing two things, no? We have here.
Yeah, see, because it says they want to see if it's their educational level of managers in startup companies is independent of the country they are from. So they're comparing United States and Korea.
Yeah.
So I'm gonna agree with you and say test of two proportions.
Yeah. Okay.
Okay, number 3.
Number 3, I am going to read. Try.
Okay.
A human resource manager reported that from a recent involuntary reduction in force F at her company. You are an attorney and want to determine if age discrimination was a factor.
Yep.
It is illegal to discriminate against employees because of age. The company reports the number of employees in two groups: 40 years old or younger and over 40 years old. There are reports of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis? Okay, in the beginning, it's telling us that we have two groups, but then they say they also reported the number of employees in each group who were terminated.
Yep. But there's two groups. And they're going by age. So is age quantitative or categorical?
One age, two ages.
They have two age groups.
Yeah.
Over 40 and under 40.
And this is categorical.
You think it's categorical?
Yeah, because you can't say like four ages. I don't know. What do you think?
I thought age was quantitative. And that can be, like, let me look it up.
Like 14 years, 15 years, 16 years.
Let me look it up real quick.
Yeah. Because it's like there are two groups divided by age.
Yeah.
It's like you'll have one group for people that have like 40 years old.
Yeah.
And the other are over.
Yeah. It says a quantitative variable is a naturally measured as a number for which meaningful arithmetic operations make sense. Examples are height, age, crop yield, GPA, salary, temperature, area, air pollution index, etc. So age is a quantitative.
Okay.
And that's the majority of what we're looking at. They're in two groups and they're grouped by age.
Yeah.
So I'm going to say it's independent sample T.
Yeah, because the other group doesn't have anything to do with less than 40 years old or more than. They are different groups. They don't depend by each other.
Right. They don't depend on each other. The only thing they have in common is they're both in a reduction in force, which is basically they're losing their job, and the attorneys want to determine if some of the people were just laying off old people, or if they were just laying off young people. Because in the US, it's illegal to discriminate against age.
Ah, okay.
So yeah, I'm going to go with independent sample T test.
What about this part? You want to determine if both age
groups are treated equal. Yeah, you want to determine if more of the people, or if the age groups were equal. If the over 40 age group was equal to the younger than 40 age group. So if there were 10 people in the over 40 age group and 20 people in the younger than 40 age group, then they're different. And to determine if they're different, we're going to use the independent sample T test.
Independent sample T test. Well, it's good to be with you today. I understood a little bit about the difference between numerical, categorical.
Yeah, and that's the first question that we're supposed to ask. I don't know if you have, did you get that testing mean flow chart?
Testing mean for chart?
Yeah, let me unshare, and then I'll bring it up and show you. Okay, where'd it go? Okay, so he sent us this one, and I think we used it on our last test.
Yeah.
And it has this stuff down here. So the first question up there is are they quantitative? These are all quantitative. But on this one, which is also in in our resources, there's another one like this, and it has both the quantitative and the categorical. Quantitative and categorical. And that's under resources and in our math thing. Under, if you scroll all the way down to the bottom after week 14, it says resources. It'll have a flow chart on there that you can print out and use. I can't hear you. Can you hear me? Can you hear me? Hello? You can hear me? I can't hear you. I can't hear you. Oh, lost him. Dang it.
You have an internet connection?
I do.
Okay.
Do you?
No.
Ooh, that's weird. Let me see if I have one on my. Ooh, where'd my tablet go? It's probably upstairs. I have one on my. What does it say?
Nothing.
Do you have an internet connection?
No.
Can you
Sure.
hear me now?
Yes. Hello, welcome back.
Okay.
Okay, back to where we were.
Question 5.
Thought we were on 4.
4? Ah,
Did we
okay.
do 4? Do you want me to read it?
No. Yep.
Okay, a survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis?
Okay, we have a total of 248 players and 52 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population. This is not paired.
No, and because it has
Now I realize it's not paired.
paired. Let me see if I can share. You're right here where it says 48%.
Yeah.
And right here where it says proportion. So if we're dealing with a percentage and a proportion, and we're looking for a proportion, it's categorical. So it's got to be, yeah, this question is categorical, so it's got to be one of these 3 tests. And I'm going to say that it's going to be a 1 sample or test of 1 proportion.
1.
Because all we're determining is heavy lottery players.
Yeah. I was confused about this part. You want to determine if the population proportion of male heavy lottery players and the proportion of males in the population. I was confused thinking this is 2 proportion.
The 152 out of
And do you
so
think
152 out of 248 is actually the sample or the p-hat. The total sample is 2,406, and we know that 58% of that is. Please don't shut down the internet. Okay. You can't. Hold on just a sec.
Okay.
You already started it back up and it's not coming up? What are you trying to get into?
Yeah, there's no class.
Do you want me to get my tablet? See if you can do it on my tablet?
Hold on. think it might be working. Oh, there we go.
You did work.
Yeah.
Okay, sorry about that. Max. So do you agree that it's a test of one proportion? Oops, let me stop sharing. Oh, sorry, I'm back. Herman, are you there? Hello.
Hi again. Hello.
Can you hear me?
Yes. Can you hear me?
Yes.
Okay. And okay, for question 4, at the end we have here, you want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population.
Yeah, so we're looking
the-
at a proportion against a population.
It's not 2 proportion, it's just 1 proportion against.
Right, just one
the
proportion.
population. Okay,
Does that make sense?
yeah.
Okay.
Okay, question 5. A student project compared the effectiveness of 2 different combinations locks. One of the locks turned close while first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the books is easier to open. Which hypothesis test would be most appropriate for this analysis? Okay.
So we have 2 locks, and the person is being timed to open 1 lock and then timed to open the second lock. So it's 25 students, and they each are given 2 locks.
And this looks like chi-square test.
Is it categorical or is it quantitative?
You have one lock, two locks.
And they're
25.
timed. They're timing how fast they can open them.
I think it's numerical.
Yes,
Numerical.
it is quantitative.
Quantitative.
Yep.
And
So it's going to be the top 5. It's one of the top 5. One sample Z, one sample T, paired sample T, independent sample T, or ANOVA. Those are the options.
okay. It's like each student was given the 2 locks.
Yeah. Do you remember when we studied the paired sample T test?
Yep.
You remember one of the examples was they had boys lighting fires, campfires, and one boy tried it with steel wool and a battery, and the other kid tried it with like flint and steel, and they timed which one was faster. That was a paired.
And this is independent. That one.
No, because one student has 2 locks. So they're being timed for each one. So I think it's paired.
Yeah. Yeah, because each student had to play with both of the clocks, the locks.
Yeah.
Okay, next question.
Okay, a bank employee a bank employs 2 appraisers. When approving borrowing for mortgages, it is imperative that the appraisers values of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Okay. And which confidence interval would be most appropriate for this study? Because the next 3 questions were identifying confidence intervals. So we've got 1 house and 2 appraisers. So I'm going to say it's paired.
It's paired again.
Yeah. This is a confidence interval, though, they're asking about.
Yeah, I agree because
I think we had one of those on one of the quizzes. I agree.
yeah.
Okay, number 7.
In a Wall Street Journal article on satisfaction, it's like I'm a Chinese reading this. Okay. In a journal article on satisfaction with career path, the percentage of psychology major reporting they were satisfied with their career path was reported. They said that was also reported for accounting measures. You decide to construct a 95 confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study?
Okay, so first of all, they're saying the percentage of psychology majors, and then second of all, yeah, the percentage of psychology majors. So when we're dealing with percentages of anybody, is it quantitative or categorical?
Categorical.
Right.
As you said.
So I'm going to say that it's because we're dealing with
one proportion.
Well, we've got psychology and then we've got accounting majors. We're comparing psychology to accounting. So I would say 2. Does that make sense?
Interval for 2 proportions.
Yes.
The last one.
Yep.
Okay, can you help me reading this question 8?
Yeah. Double stuffed Oreo cookies are supposed to have twice the filling as regular Oreo cookies. You and some friends decide you want to know if the true assertion by the company who makes them, which is basically that there's twice as amount of filling in a double stuffed cookie than in the regular. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount of regular Oreos. Which confidence interval would be most proportion or most appropriate for this study? Take a.
Yeah. First of all, I have to understand the English.
So do you know what a double stuffed Oreo cookie is?
Double stuffed Oreo cookies. I had a companion. He only ate these Oreos. Oreos cookies, and he drank juice in the mission. Just it. The juice was like a lot of sugar in that juice, and even when he took medicine, he used the juice to drink it.
Interesting.
Yeah, that's fine. And I don't know if it's the same Oreos because it was like black.
I'll show you.
It was black. Yeah, Oreos.
Double stuff. They have twice the amount. Can you see that? Twice the amount of filling, and these are a regular. Here. So that's a regular Oreo, but a double stuff has twice the amount of filling.
What does it mean? Estimate the true mean filling amount of double stuffed Oreos.
Okay, so this is a regular this is a regular Oreo, and see it has this white stuff in there.
Yeah.
That's the filling.
Yeah.
And then
yeah.
Let's see if we can go. There it is. And then a double stuff has more filling. It's supposed to have twice the amount of filling as a regular Oreo.
That thing is filling.
Yep, filling. This white stuff in the middle is filling.
Feeling. I thought it was like something to feel it, like you like to feel something. I thought it was that. Okay, and this is they are testing two kinds, no? Comparing this
But if you
regular.
read it, it says you need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount of Oreos. So we're not actually getting the confidence interval for the regular Oreos. We're only getting it for the double stuff.
Okay, you take a sample of 55 double stuffed Oreos cooked and measure the amount of filling in each one.
Yeah.
You need to construct confidence interval to estimate the true mean filling amount of double Oreos in order to compare.
So is it quantitative or is it categorical? We're measuring filling.
Okay. It's not categorical.
Yeah, it's numerical. It's a quantitative.
Quantitative.
Yeah, and I'm going to say because we don't have the standard deviation, that it's going to be a one sample T. Confidence interval.
Yeah.
Well, I like these next answers. They're easy.
Okay. Which one of who is going to read? I'm reading.
Go ahead. Go ahead. You already started.
One of the following best defines the notion of the significance level of hypothesis test. One, the probability of observing a sample statistic more extreme than the one obtained, assuming the null hypothesis is true. The probability of the type 1 error, the probability of rejecting the null hypothesis, whether it's true or not, the probability of the type 2 error.
Okay, so they're talking about level of significance, which is usually that alpha. Alpha equals 0.05. That's what a significant level is.
Yeah.
So that's the probability of a type 1 error.
And when you talk about the level of significance, the type 1, okay. Oh, this I don't know the answer, and I will agree. Question 10. Which one of the following best defines the notation of the p-value of a hypothesis test? The probability of the type 1 error, the probability of the type 2 error, observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true. And okay,
so we're talking about p-value of a hypothesis test. So the best definition of a p-value is the probability of observing the sample statistic more extreme than one actually obtained, assuming that all hypothesis is true.
Okay.
Suppose you can create a 95% confidence interval for a mean and get 10 and 20 You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? 95% of the sample means are between 10 and 20. 95% of all 95% confidence intervals are actually contain the true mean. And 95% of the data are between 10 and 20. Or there is a 95% chance that the true mean is between 10 and 20. It will never have the word chance in it in a 95% confidence interval. So I know it's not number 4. I think
Okay, let me try to understand. Suppose you create 95 confidence interval for a mean and get 10 and 20. Okay. You have been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? 95 of the sample mean are between 10 and 20. 95 of all 95 confidence intervals actually contain the true mean. 95% of the data are between 10 and 20. There is a 95 chance that the true mean is between 10 and 20. Is this talking about the true mean?
Yes.
Okay. Use the following information to answer the next 3 questions. You take a simple random sample of 100 adults from a town in the Western Union states to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P equal 0.3 or 30%. Okay, what is the mean of the distribution of the sample proportion?
We're basically asking, what is p hat? What's your mean?
The mean is P.
Yep. So what's your answer?
0.3.
Yep.
Okay, we have to calculate the standard deviation.
Yep. Or you can stick it in your one proportion. You have 30. Your proportion is 30, right? 0.30. And we're looking for the standard deviation.
1 second. Okay.
And this is the one that I got stuck on. So hopefully you know the answer.
Okay. Okay, what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? Okay, let's try to think. This is related to question the information, use the following information to answer the next three questions. What is the probability that your random sample 100 adults will have a sample proportion less than 0.25?
Oh, okay. So I forgot that we had this information. Ah. Okay, so if we have 3, I know the calculation. So we have our P is 30, and then we're going to subtract 1 minus C. So 0.30 minus 0.25 over the square root of 0.25, 1 minus 0.25 over 100. And let me see if I get an answer. Five, 0, 5 over 1 minus 0.25 equals 75 times 0.25 equals 5 by 100 equals 0.043312 divided by 0.043312 equals 1.15 to my probability applet, right? Normal probability. And we put 1.154 in. That's less than, right? 124. Did you see what I did?
Yeah, I want to find the formula you used.
It is, let me see if I can find it. It is P minus P hat over the square root of P hat times 1 minus P hat over N. Let me see if I can find it in here. I think it was in 17. No, maybe it's in 18. Oh, there it is. We're finding the Z value. Can you see right here? P hat minus P. So our populate, maybe I did that wrong. Ugh. P hat minus P. So I did that wrong. I think 0.25 minus 0.30.
I lost you in the. Now I can hear you again.
Can you see this, what I'm sharing on the screen, the Z-score for the proportion? It says P hat minus P over the square root of P times 1 minus P over N.
Yeah.
That's the formula.
What you have down there is the formula of standard deviation. Yeah. Okay. I can see. So there's this score.
Okay. Let me see if I did this right though. 0.30. Let's see, 1 minus 0.30 times 0.3 equals 1 divided by 100 equals squared 0.458257. Negative divided by 0.0458257. 109. I don't even think that's one of the answers.
How did you find the P? The P
It's right here.
hat will be the
25.25.
point. Okay. You use the Excel tool, no, to find the P hat.
Well, we know that it's going to be 0.25.
We have the P, the proportion, no, which is P, and we need the X to know which one is. Okay, I didn't.
We know.
Okay.
We know it's 25.
Question 14. Yeah, I didn't look at the question. Yeah, that one.
And if you look at the problems that we were working on, or the review questions, they're the same as the ones that we're taking right now. And the 4 answers that they had, B was one of the answers, 0.124, and that's what I got for my answer. So I'm hoping that's what it is. Like I said, I wasn't really sure when I was trying to figure it out, but I forgot that it said that we're using this information as well for these. Okay, are we moving on?
0.125.
124.
0.124.
Yep.
Yeah.
Oh boy. Okay. Acupril is meant to control hypertension. A clinical trial of Acupril, 2,142 subjects were divided into 2 groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril, and let P2 be the true proportion of people who experienced dizziness but did not take Acupril. Create a 95% confidence interval for P1 minus P2. Input the margin of error, lower and upper bounds, and round numbers to the nearest 3 decimal places. Okay, so we're going to put all this information into our spreadsheet. Okay. Spreadsheet. 2 proportions. So the first one, how many do we have in that first group? There were 61 out of 1,563. I think. Let's see. Yeah, 61, 179 out of 15. Okay, and then we're having, do we know, 95% confidence interval. And we're looking for the upper and lower bounds. What are we looking for though? Okay, so if we put that all into our spreadsheet, did you put that information in? Were you able to put that in? I can't hear you. Armand? Are you there? I can't hear you. Okay. So I put that into my spreadsheet and I got my confidence interval, the margin of error. To get the margin of error, we have to add the two together and divide by 2. Yet. I hate finding margin of error. It's like the worst. Zero, zero, 3. 0.29. Oh, dang it.
Hello?
Hi, I
Hi.
can hear you now.
I'm going to use my phone to see if it improves.
Okay.
Okay, I think I will be able to do this one, this part.
Okay, I put all the information into the spreadsheet. The 2 samples z-test 2 proportion.
Yeah,
I put the
you
61
got
and I got
61. Okay. 1563. 15. Five.
0.039.
This is 2 proportion.
Yes.
Fif- 1563. 15. 579. Okay. Okay. I think I have to step out,
Okay.
and thank you a lot for your help so far.
Yeah, no problem.
And,
Thank you. We'll see
and,
ya. Good luck on the test.
Okay. Thank you. You too.
All right, thanks.
I won't say good luck for you. I will say good job. Good luck for me. I have to. Yeah, I need the luck.
Yeah. All right,
Thank
bye.
you. Bye.